Good morning everyone, my name is Arsenia Twinkle Star and today I'll be discussing about graph at linear inequalities in two variables. But before discussing about this topic, I would like to teach you about how to determine if our problem is a linear inequality or linear equation. So in linear inequality, the sign that we'll be using is less than, greater than, less than or equal to, and greater than or equal to. But in linear equation, the sign that we'll be using is only the equal sign. Since I already have discussed the difference of linear inequality and linear equation, I'll be now discussing about graph at linear inequality in two variables. So our problem here is negative 3x plus 4y is greater than 12. So our first step to do here is rewrite. So instead of greater than, we will change our sign to equal. So let's rewrite. Negative 3x plus 4y equals to 12. Right? Then after rewriting our form, the next thing is to solve for our x and y intercepts. Okay. Okay, so in solving for x, we're going to make our y 0. Okay, now equals 12. So 4 times 0 is 0, so you could just simply cancel it out. So next, the number that we have left is negative 3x. Okay, so then after that, we're going to be dividing both numbers with negative 3x. Okay, so negative 3x times divided by 3 is 0, and 12 divided by 3 is negative 4. So x equals to negative 4. So our plot is negative 4, 0, x, y. Then now we'll be solving for our y. So we will be doing the same process, but instead of the y being 0, our x will be 0. So negative 3, 0 plus 4y equals 12. So we'll do the same process, cancel, that's negative times 0 is 0. So all we have left is 4y equals 12. So we're going to be dividing each number by 4. So 4 divided by 4 is 0. Then 12 divided by 4 is 4, 8, 12, 3. So our y is 3. So 0, 3. Okay. Once we already have solved for our x and y intercept, our third step is to plot them in the Cartesian plane. Let's start with our third step, which is plotting in the Cartesian plane. Once you're done drawing your Cartesian plane, you'll be plotting your ordered pairs. So for our x, we got negative 4. So you're going to be plotting negative 4 in the x-axis. Negative 4. Then our y is positive 3. There you go. Once you're done plotting the ordered pairs, you'll be doing a boundary line. So there's actually two types of boundary line. First is the solid line, then the broken line. So boundary line is used for signs like greater than or equal to or lesser than or equal to. But broken line, we'll be using it for greater than and less than. So look at our main problem. So the sign here is greater than. So when it's greater than, our boundary line will be broken line. So now let's have it. There you go. So that is our boundary line. So once we're done plotting and plotting our boundary line, we'll be doing this next process called the test point. So the test point's usage is to determine which side to shade, either here or in the opposite side. since we have our ordered pair that we'll be using as our test point, which is 0, 0, we will be solving for it. So in number 4, it's actually the same process as illustrating linear inequalities in two variables. So let's try doing it right now. So the first thing to do is write the original problem, which is 3x plus 4y greater than 12. So then after that, we will be changing x and y to our ordered pair, which is 0, 0. This is our x and this is our y. So negative 3, 0 plus 4, 0 is greater than 12. So as you all know, negative 3 times 0 is 0 plus 4 times 0 is 0. So 0 plus 0 equals to 0. Then, so is 0 greater than 12? No. So it means our answer is false. So since it is false, so this is where our point is located, right? Our test point, you will be shading the opposite side. Unless it says true, you'll be shading the side where the test point is located, which is in here. The opposite side that I have shaded. That's all for today. Thank you everyone for listening and have a great day.